participants who have registered for the conference to please come to the auditorium so that we can begin the formal program.
At the foot. Madam.
Thank you so much. It was truly graceful and uplifting. Thank you for that applause that you had for the. May I request the stage team to please come. Now we move on to the most prestigious. It's my proud privilege to invite Priya sir, Shalaja madam, and Venu sir. Request I now request our highly accomplished chief guest, Dr. T. Harinath sir, General Manager, ECI Hyderabad, whose expertise and experience brings immense value to this gathering, to please come on the stage and occupy his stage. Ladies and gentlemen, let us welcome all with a big round of applause. To mark a graceful beginning, we now move to Jyoti Prajwalana, followed by prayer song. I request all the dignitaries to participate. I also request Dr. M. Shishidhar sir, Principal Bhaskar Engineering College, to please be on the stage. Sir, may we have your presence on the stage, please? Shishidhar sir, please. I also request Soumya and Sufala to come for the prayer song. May I also request all the dignitaries seated off the stage to please rise up for the occasion. I request the audience to please rise for the prayer song.
Ladies and Madam. కవర్లోనే పెట్టండి కవర్లో పెట్టండి
Thank you so much for setting the right tone. Thank you. Please be seated. Now, I invite the convener for the International Conference on Emerging Trends in Engineering, Technology and Applied Management Sciences, Dr. K. Tirupati Rao sir, to deliver the welcome address.
Respected today's chief guest, Dr. T. Harinath sir, DGM, ECL, Hyderabad. Respected principal sirs, co-chair and co-conveners, the chairpersons of different places, the the head of the departments and authors, such scholars, global wide, present media, participants invite to this the international conference. The intention of this international conference is to create the common platform, to present, otherwise express the trends, emerging trends in the field of engineering, technology, and applied management sciences to enrich the Vikasit Bharat that all we are hearing from the Prime Minister and technocrats and bureaucrats. What is the exactly meaning of Vikasit Bharat means that we have self-dependent, self-sufficient. At the time of the independence, we were suffered for the shortage of the food grains in 1947. Now the status is that we are the sufficient in the food grain that is not serve the comfort provided to the human beings and industry. All we technocrats, we have to do, we have to develop, we have to research and see such that we must provide the comfort to the human being and the industry. Under that category, we have to concentrate more productive research in the field of all this engineering, technology, and management science. That was the intention to start this one. Under the international conference, we had invited the researchers, the research scholars to provide their views in the form of the text, means papers. Okay, we had received 515 the different category papers global wide, out of which our national, international reviewers selected 320 papers in 5 different tracks, and the same thing communicated to the authors, and today that is finalized, and today we are in position to publish 320 papers in 5 different tracks. That is the credit goes to our organ, mainly this international conference, the co-chair and the co-conveners mainly, okay, due to their efforts with the help of head of the departments from Vasudevi College of Engineering as well as Vasudevi Engineering College and Pharmacy College all around Warangal, as well as we had taken help from the NIT and other colleges also. With the help of that, we, okay, 320 selected for publication is very great number, and received is 550. That's the data we and the tracks we had divided into 5 categories. First track is electrical and electronics engineering related. Okay, most of the publication is interdisciplinary. We know that interdisciplinary, but even though the major part, major idea, major thing is related to electrical and electronics. They divided, otherwise classified into track 1. Second one is most popular engineering, otherwise technology. Nowadays global wide is computer science.
From computer
science is track 2.
In computer science, we finalized 120 papers for the publication, and track 3 is civil and mechanical related papers. Track 4 is applied management sciences related, and track 5 is the basic sciences, means physics, maths, chemistry related papers is classified under the track 5. Okay, this way we had selected. After selected, to provide the comfort to the authors, what we had is the hybrid mode. We selected this conference to same thing. All we technocrats, we are here to provide the comfort to the human being and production sector. Keeping that same, we given hybrid mode, means those who are having the comfort to reach Warangal, then there is a offline provision is there for the presentation. At the same time, those who are not comfort to reach Warangal, for them we are provided the online presentation also. At the same time, the session chairs also offline as well as online. That provision is also there to provide the actual our intention is to know the views, expectation of the global wide, all universities with international level within the India. That was the intention. We reached 90%, not 100%, and we are collaborated with India as well as Netherlands, Saudi Arabia, and remaining NITs and some universities, okay, other universities also we are approached and they are accepted and they are participating and they are supporting and they had given the guidance to this one. And next, especially not only concentrated on authors, and we also concentrated the expert, otherwise keynote speeches from the specialized experts like today's guest, Dr. T. Harinath sir, DGM ECIL. Nowadays, software we are advanced. We are exporting the software related things to the US also, but manufacturing of chips is, we are very, very behind it. That is the actual productive sector. All of we know that one. Any nation growth depends on 15% on service sector, 85% on production sector. Okay, if we concentrate only service sector, we won't grow. Okay, that is why this, okay, software, most of the softwares comes under the productive sector, even though manufacturing of chips is very, very important. The main, okay, nowadays we are growing under the guidance of the great Prime Minister. The slogan is Vikasit Bharat. Okay, under that we are improving, and with the keeping that in view, first preference we given to the ECIL, the first keynote address, otherwise the expert lecture from the ECIL. At the second keynote address from the NIT, professor from the NIT, so that education related. The third one is the international expert from Saudi Arabia, and one more industrial, the expert from the Netherlands. Like that, we planned the balanced and we planned this international program, and I am requesting all the participants to utilize these 2 days and try to gain productive knowledge. Okay, on paper knowledge, not on paper knowledge, productive knowledge from these experts as well as the views of the authors. Views of the authors. Please, you understand what they want to. Okay, all the authors, and please understand and gain this one. That is the suggestion as well as the expectation from this international conference. Thank you, everybody.
Thank you so much for your detailed welcome address as well as the word of advice for all the participants. I now invite our co-chair, Dr. Ranjit sir, to please address the gathering.
So, respected chief guest and dignitaries on the dais, half the dais, faculty members, very good morning all of you. First I would like to invite our directors, Vani Madam, Vahini Madam, onto this inaugural session. Thank you. So it is my immense pleasure to address this distinguished gathering as a conference co-chair. On behalf of R&D cell, first I would like to highlight the few achievements of R&D. Why? Because this event is purely related to research and innovation. Our research and development cell, Vagdevi College of Engineering, recognized as a research centers by JNTH, EEE, CSE and Mechanical. Our faculty published various reputed journals indexed in SCI, Scopus and etc. So in addition to this, our institute have the various funded projects sponsored by AICTE, UGC, TechWhip. So this is a great achievement for our institute. And coming to this conference, I'm proud to share that this is the first conference organized by Research and Development Cell, even though earlier we have conducted under the leadership of Principal Sir and other departments, but this is the first conference conducted by R&D Cell. It is a proud moment for me. Thank you all. This conference represents the days of dedication, collaboration, and careful designing and planning. We designed a theme for this conference that is related to Vikasit Bharat 2047. So it is highly represent the India's context, and our conveners are detailedly explained everything. We have designed the different tracks. It benefits all the interdisciplinary research areas. So that is also in the context of Vikasit Bharat 2047. At the outset, first, I would like to thank our chief guest, Dr. T. Harnath sir. In spite of his busy schedule, he attended the conference and delivering the session. Thank you, sir. It is truly inspiring for us. I hope this platform is the best for researchers, faculty, for sharing their knowledge, collaboration, so to enhance the research output effectively. I hope all the participants use this platform and interact with our experts. Thank you all for giving this opportunity.
Thank you. Thank you, sir. May I now request the conference chair, Dr. K. Prakash sir, to formally declare the conference open.
Distinguished today's chief guest, Dr. T. Harnath garu, DGM, ECIL, Hyderabad, for accepting our invitation in spite of his busy schedule. Thank you, sir. And my fellow colleagues, Professor Tirupati Rao and Dr. Shashidhar, Shelja madam, and other co-chairs, directors, Vahini madam, Vahini madam, and Dr. Venu, faculty members, researchers, academicians, very good morning all and warm welcome. It is my honor to welcome you on this international conference on emerging trends in engineering, technology and applied management and sciences. In today's rapidly evolving world, research is the driving force behind innovation, sustainability, and societal progress. Conferences like this provide an important platform for sharing knowledge, fostering collaboration, and encouraging interdisciplinary activities. Recently, our management has magnanimously announced research promotion policy at a bigger level, which includes patents filing, incentives for patents grants, journals, conferences, and whatnot. Almost, even including the seed fund, they have also granted. It's a really a wonderful opportunity for all the researchers, especially faculty members. They have to they have to utilize this research promotion policy and make use of it. And I hope year on year, the fund from the management should be increased. That should be the true spirit of this research promotion policy. And once the research starts, automatically experimental setup will increase. It's so we cannot be confined to only simulation kind of research. A day should come where at least at a smaller pace we need to go for an experimental setup of projects. Once these experimental setups are beginned, we can also hope for a consultancy. So that should be the aim for giving this research promotion policy. And this conference also reflects our commitment to promote quality research and bridging the gap between academia and industry. In the recent times, our institution got 1 crore rupees sanctioned by IP Facilitation Center for implementation of IPR components, a sub-component of the MSME Innovation Scheme during the financial year 2023-24. So this is a great opportunity given by the MSME central government, where I wish everyone should utilize this IP Facilitation Center. This is not only for our institution, it is at the entire region of this particular Warangal, Khammam and all the 4 districts. Even Hyderabad industries are also coming forward to utilize this IP Facilitation Center. We have also received 90 lakhs worth equipment sanctioned by the ACTE for the establishment of the Idea Development Evaluation Application Lab in the recent times. 50 lakhs worth equipment was sanctioned by ACTE for the establishment of Aerovision Drone Lab. So even the drones is also order of the day. So we have also well equipped with the drones equipment already sanctioned. Very soon we are also going to inaugurate it. And a couple of innovation grants received by our students, that too from the MSME scheme. 6 lakhs sanctioned for the innovative idea titled Petroscam Detection System by Muhammad Sufia, student of BTech ECE, has been accepted by the MSME Business Incubator for funding under the MSME scheme. So this is one of the proud achievement that students also started doing the innovation. Apart from this, in the 3 years, in the last 3 years, I can say 3 to 5 years, we have received various projects and schemes funded by the various government funding agencies, including UGC, AICTE. To name a few, we have got many FDP programs, SPICES sponsored by AICTE, PELSCS academic license, sanctioned by the Switzerland industry worth of 18 lakhs, and MODROPS by the ADSP lab and MODROPS by PED lab, sanctioned, both are sanctioned by AICTE worth of 19 lakhs. Similarly, we have Prerana scheme, government, and even we have also earlier we have conducted conference with the help of the fund sponsored by the AICTE. That is conducted by the Department of MBA 2 years back. Even we have a Typhoon HAL research equipment worth of 18 lakhs. It was a award by the Switzerland company, which was conducted at the Asia level 10 of 10 award. So one is VIT has achieved, then the other one is in the South India, Vagdevi College of Engineering has achieved this worth of 18 lakhs. So that is also one of the proud moment to share on this August gathering. Similarly, we have a couple of TechCube grants received by the JNTU Hyderabad. Almost 11 lakhs we have received, which was sanctioned by the JNTUH. Out of 13 TechCube grants, which were declared for the private institutions under the JNTU Hyderabad, we have received 5 out of the 13. So that was the research which was done by our faculty members. Really, we have to congratulate every staff member who was very much instrumental in this particular TechCube grants. So overall, as of now, in the last 3 years, I can say 1 crore 2 lakhs was received in the form of various funding agencies by the institution. Apart from this, we have an active VIBA center, Vagdevi Incubation and Business Accelerator, which was taken very prestigiously by our group of institutions, Vagdevi colleges, where students, faculty, all the young budding innovators were given financial support, technical support. In all respects, they are also incubated. Around 7 startups were already successfully graduated. They were also given the, they are also registered as a companies by name Samaype, Sunrise Mitra, Samruddhi, Arisa Growth Farm, Gravy Stores, Eco Waste 360 Degrees, Scalebucks. And out of these, 3 startups are incubated in the V-Hub and 1 startup is incubated in the T-Hub. So this is the brief profile of the research and innovation at Vagdevi College of Engineering and Vagdevi colleges in particular. Thank you.
Thank you so much for briefing about the institution, its growth, that it has been compounding towards research and innovation, sir. Thank you. Now, I request Dr. C.H. Vahini ma'am, the Director of Vishwambar Educational Society, to address the gathering.
Respected members and the dignitaries on the dais, our chief guest Harinath Garu, DGM, ECI, Hyderabad, and respected principals, deans, control for examiners, esteemed faculty, researchers, and staff, my dear students. Namaskar. A warm welcome and good morning to all who have presented here. It's a privilege to me to stand in front of this occasion, remarkable occasion of inaugural function as a Vice President of Vishwambara Educational Society. It's a great honor. Everything is told by our esteemed principal and our co-convener about the program. Just I want to share the thought of the conference and significance, what's going on here. As a world, digitalized world, now the innovation is not optional, it is essential, it became essential. So engineerings are not confined for the machines, and technology is not confined for the devices, and management is not processing alone. If these three connects, engineering, technology and management, if these driving force together, if we drive, there will be a global transformation. So basically, based on that, we have organized this conference based on this thought. And for the students, I want to convey this. This is not an event or academic program. It's a launch pad for the younger minds to experience your ideas, to get your creative thinkings, and what are the ideas you are getting, that should be getting to the execution, and what you are going to take the challenge of knowledge that is going to be in the action. And I want to be collaboration between the experienced speakers and your young minds, so that there will be a lot of change. The society needs the younger minds. So this is the best platform, this is your best day where you are going to experience a special era around you in terms of creative thinking, in terms of knowledge, in terms of ideas into innovation, in terms of collaborations. Though this is the best platform, we are going to enjoy these 2 days. You have the great speakers, as our vice principal told, different speakers. In spite of their busy schedule, they have given so much of time to share the knowledge, enlighten your knowledge, experience their views, and encourage your young minds. So utilize these 2 days and go with the new ideas, go with the new connections, go with new thinking, go with the new collaborations. So I really thankful for this experience, and also I congratulate all the committee members, organizing committee members, faculty members who have striven since 1 month to struggle this and to get success of this conference. Once again, I congratulate to all of you, and I also especially thankful and gratitude to our Chief Guest Harinath Garu to grace this occasion, because of he is a very busy man. In spite of their busy schedule, they have come for long to address you, enrich you, and enlighten you. To utilize these 2 days, enjoy, encourage yourself, get confident, and go with new ideas. Thank you so much for your.
Thank you so much, ma'am, for those inspiring words. I'm sure that the young minds here are now aware of the purpose that they are here, not only for presenting the papers, but also to learn from the various researchers that will be budding and sharing their knowledge here. Thank you so much. I now invite Dr. Shailaja ma'am, to please to introduce the chief guest.
Very good morning to all the dignitaries on the dais and off the dais, controller of examinations and distinguished guests, head of the departments, and my dear faculty and students. We are grateful to you, sir, for accepting our invitation and honoring us with your presence today. It is my great privilege to introduce our esteemed Dr. T. Harinath. Dr. Harinath is currently serving as a Deputy General Manager at Electronics Corporation India at Hyderabad. It is a premier organization contributing to India's strategic and technological advancements under atomic body. And he holds a PhD in Electronics and Communication Engineering from JNTUH, along with MBA Operations Research from IGNOU, and Bachelor of Degree from Osmania University. And he had a remarkable contributions in the field of electronics and communication engineering. His areas of expertise: digital, analog, and RF systems, telecom and radio communication, encryption systems. He has worked on prestigious projects. All of you give background. He has worked on prestigious projects, Brahma IP Encryptor. It is a very prestigious project, and digital radio system, electronic counter measure systems, and digital switching systems. He has a strong specialization in embedded system, VLI design, and using Linux, FPGA, and encryption algorithm development. And he has his notable contributions. He is introducing innovative hardware programming based design methodology, reducing dependency on microprocessors. He has also published several research papers in reputed national and international journals and forums and conferences. Currently, he is working in the development of software-defined radio. His vast experience and technical excellence are truly inspiring to us. I am requesting Dr. Harinath sir, please your valuable suggestions and inputs to R&D growth of our institution. Thank you, sir. Thank you, one and all.
Thank you, ma'am, for the introduction to the guests. Now I request Dr. T. Harinath sir, the DGM for ECIL, to deliver the address to the audience.
प्रणो देवी सरस्वती वाजयभिर्वाजनीवती ధీనామవిత్రియవతు. ఇది మీకు నేను కొత్తగా చెప్పక్కర్లేదు, ఎందుకంటే ఐ థింక్ ఆల్ ఆఫ్ యూ కెన్ అండర్స్టాండ్ తెలుగు. ఇనిషియల్లీ ఓకే, ఇఫ్ యూ కెన్ అండర్స్టాండ్ ఐ విల్ స్విచ్ ఓవర్ బిట్వీన్ తెలుగు అండ్ ఇంగ్లీష్ అకార్డింగ్ టు మై కన్వీనియన్స్. ఓకే. వాగ్దేవి ఆ పేరు వినగానే సరస్వతీదేవి మనకు గుర్తొస్తుంది, ఎందుకంటే మన నాలుక మీద ఆడేది ఆవిడే, మన జ్ఞానానికి మూలం ఆవిడే. ఆ జ్ఞాన సరస్వతి పేరు మీద ఉన్నటువంటిది ఇక్కడ చిన్నారులందరూ మరి ఆ సరస్వతీ మూర్తులే అవ్వాలి కదా. మామిడి చెట్టుకి మామిడి కాయలు కాక ఏమొస్తాయి, మామిడి పండ్లు కాక. కాబట్టి ఖచ్చితంగా ఇక్కడ మీరు మీ శ్రద్ధ చూపిస్తూ ఉంటే ఆటోమేటిక్గా అలా అవ్వాలని కూడా నేను కోరుకుంటున్నాను. దానికి మిమ్మల్ని తీర్చిదిద్దడానికి ఇక్కడ ఎంతోమంది మేధావులు చక్కగా తిరుపతిరావు గారు, ప్రకాష్ గారు, వాహినీదేవి మేడం గారు, రంజిత్ గారు, శైలజ మేడం, కంట్రోలర్ ఆఫ్ ఎగ్జామ్స్ వారు, వేణు గారు, ఇలా ఎంతోమంది, నాకు పేర్లు అందరికీ తెలియవు, దయచేసి ఏమీ అనుకోవద్దు. కానీ ఎంతోమంది కృషి చేస్తేనే ఇప్పుడు ఈ రోజున ఈ స్థితి ఇలా చక్కగా అందరూ ఆనందంగా ఇంట్రెస్ట్గా ఈ విషయాన్ని తెలుసుకోవడానికి ప్రయత్నం చేస్తున్నారు. జస్ట్ నౌ అవర్ ప్రిన్సిపల్స్ ఆర్ టోల్డ్ అబౌట్ ది అచీవ్మెంట్స్ ఆఫ్ వాగ్దేవి గ్రూప్ ఆఫ్ ఇన్స్టిట్యూషన్స్ ఇన్ ద ఇంజనీరింగ్ యాక్టివిటీస్. It's really admiring. Immediately I told, sir, these are very good achievements. These are not small ones. At engineering level, particularly this interdisciplinary and aiming for Vikasit Bharat, the title of the international conference itself signifies how you are targeting. It is showing your ambition. And not only for just this seminar, it gives a tremendous experience for the participants to know about their job. They should rise to the occasion, use this opportunity, rise to the occasion and contribute for the nation. Of course, in that process they also will develop. Vikasit Bharat is meant for development of the nation. India should be a developed country by status. So far we call it as developing. By completing 100 years of independence, 2047, it should be a developed nation. So for that what we have to do, that in fact you, this faculty and the conveners and all the people assembled here are advising the children, come on, get up, rise to the occasion, know your responsibility and go ahead. Like that. That is the message in fact you are giving with this title itself. When the moment I came here, when the program started with the dance program, really I congratulate those two girls who have excellently performed that. And after that the prayer song and the prayer, the way it was done, I am really very much pleased. And it is signifying the real name, whatever is put, the management, whatever it has put the name Vagdevi, it really suits. And you are working according to that. I wish this international conference will yield all good results. I wish you all a success and brightful future. And I think we can continue for the next program. Keynote session anyway will be there afterwards. So I thank one and all, particularly Shailaja Madam and Ranjit Garu, who had contacted me regularly and briefed me about all this. And in fact, I also felt very happy. And the hospitality the people have given here, I cannot forget it. I have to express my gratitude to them on this stage. Thank you all.
Thank you so much for your kind words, sir. That truly makes us very happy that we were able to address you in a right way. Thank you so much. May I now request all the dignitaries on the stage to please release the souvenir. Can we have a huge round of applause as this gets unveiled? It's been hard work of all the committee for bringing out this. Thank you so much. May I now request all the dignitaries to felicitate Dr. T. Harinath sir, DGM ECIL. Sir, thank you so much for gracing the occasion. I request the team to please pull up a chair. Sir. Sir, I request you to please step forward and accept the honors. We will be having a keynote address by Sir post inaugural session. Thank you so much, sir. I now request Dr. Syed Riyad, sir, to please propose the vote of thanks.
Thank you, sir. Thank you very much. It gives me immense pleasure and deep gratitude on behalf of the organizing team of International Conference to have the privilege of proposing vote of thanks. At the outset, I extend our heartfelt thanks to our esteemed chief guest, Dr. T. Harinath Garu, DGM ECIL, for his inspiring presence and valuable insights that truly enriched this conference and motivated us towards excellence in research and innovation. I express my profound gratitude to our visionary management, our secretary sir, Vani ma'am and Vahani ma'am, directors Vishwambar Educational Society, for their unwavering support, encouragement and commitment to the strengthening R&D ecosystem. My sincere thanks to our respected principal sir, Dr. K. Prakash sir, the conference chair, whose leadership, dedication and constant guidance have been backbone of this conference. I also extend my gratitude to our vice principal, Dr. K. Tirupati Rao sir, the convener, whose constant effort, frontline leadership and meticulous coordination made every aspect of this event seamless and successful. I extend my sincere thanks, and it is our fortune and privilege to have our dynamic leader, Dr. K. Ranjit Kumar, Associate Dean R&D, the conference co-chair, whose quick decision making, strategic vision and unwavering commitment ensured the smooth execution of this conference. I sincerely thank to my fellow co-conveners, Dr. Shailaja and Dr. Venu, for their tireless efforts, dedication and exceptional teamwork that significantly contribute to the success of this event. I also extend my gratitude to all the heads of the departments for their encouragement and their graciously serving as session chairs, as well as committee coordinators and members both on screen and off the screen for their dedicated contribution to the teamwork, whose collective efforts made this conference a grand success. A heartfelt thanks to our non-technical team for their arrangements. Finally, I thank all the authors who are presenting the papers, participants for their enthusiastic involvement and valuable contributions. With this, I conclude my vote of thanks. Thank you everyone for being here with us today. Thank you.
With that, we come to the end of the truly inspiring inaugural session. On behalf of the organizing team, I extend our heartfelt gratitude to all the distinguished guests, speakers and participants for gracing the occasion and making this a memorable one. And now, as we move forward, the energy of this conference continues. We are about to begin our first keynote session. And I'm delighted to share that we will be doing this in this hall, the very next moment. So I request all the dignitaries to please take their seats off the stage so that we can hear to the first keynote speech by Dr. T. Harinath sir, the DGM at ECIL. All the participants, may I request you to please be seated in your own seats as we begin the first keynote address. Request the team to please lower the screen and to present the presentation on the screen. Technical team, kindly lower the screen.
చదవండి. ఎక్కడ పెట్టేస్తా. వస్తుందా? స్క్రీన్ మీద డిస్ప్లే కావాలి అది. ఓకే ఇస్తాం. ఆల్రెడీ
It's a humble request to all the audience to please utilize the opportunity of the knowledge sharing that we have from today's session. So I request you to please be seated in your own seats. వస్తాం. జస్ట్ నా స్విచ్ ఆఫ్. ఓకే థ్యాంక్ యూ.
morning all once again. So today I would like to discuss with you on presentation on emerging engineering trends in electronics. Actually I am from ECE, so you may think that it's only for electronics. No, in fact, when you see technology, it is disciplinary wise. But when you see as a product, then all disciplines have to work together. Otherwise you cannot. For example, if you take a computer, without cabinet, what you will do with the PCBs? Without software, what you will do with the electronics? So all have to work together. So whatever I present here, in fact you will come to know they are all interlinked and all disciplines are in fact involved. Next slide. Okay, right, okay, okay, am I audible now? Okay. So here emerging trends in electronics. These are kept in view of Vikasit Bharat 2047. When we really become a developed nation, what we will achieve? Our standard of living will increase. Our economic growth will be very good. Self-reliance will be intact. So we need not depend on anyone else for our development or testing or anything. Not only technically, financially also. Imports we can reduce and we can increase the exports so that we can demand or control other nations also. So that is actually the goal. In that, as engineering people, what we have to do, that is the need of the hour. So in that angle, if you see, already we have so many other technologies and so many things. So at present, which are in fact to be focused, or what even our government is aiming at, these are the 10 what I have listed, which are in fact priority wise we can say, but not in the same order. Don't think that first one is, that is the topmost, last one is the least one. It is not like that. All are linked. Just I have put in some order. That is not the exact order. Okay. Artificial intelligence in electronics, advanced telecom, Internet of Things. So like this all are there. If you see artificial intelligence, the name itself indicates it is intelligence but not natural. It is artificial. So some intelligence is there. Everyone will think that there is only software only. What we have to do with the hardware in that? But without hardware, software cannot work. Okay. Am I audible? So as electronics engineer, we have to focus on artificial intelligence in electronics, that is reducing human intervention. In fact, not reducing, eliminating human intervention. Advanced telecom, communications means communication between two parties. Okay, if when we develop the data speed we can increase, data volume can be increased, and the number of devices that can talk to each other also will increase. In that form we will find 2G, 3G, 4G, 5G. Now 4G is intact, 5G and 6G are, in fact 5G is almost about to be finished. 6G is future plan. So those things, that is for connectivity. Internet of Things, using the network to organize things to happen. So Internet of Things. Green electronics and energy storage. When we develop a system, we require energy. That energy must be green. Green in the sense not just in color, environmental friendly. And storage, how big energy we can store and how safely we can store those things. And then we know electric vehicles are in fact replacing so many petrol or gas driven or diesel driven vehicles. Not only the cost, even resources wise also, that is very useful, particularly in this current era, in this 2026. Everyone knows, we know, regularly watch the news also. Drones and aerospace electronics, these are in limelight nowadays. smart manufacturing, using all technology in the manufacturing field, cyber security and data protection electronics. When we transmit some data, there is every threat that someone can hijack it, misuse it, or block it. Whatever way they can do, they will try to do. To protect our data from hijackers or malpractitioners, we require some protection system. For that also some electronics is required. And when we do all these things, we require some chips to realize the circuits. Those chips we have to manufacture within our country. So that for that we have some infrastructure to be developed. So what are the existing infrastructures and what more are required, how that can be done? Electronics design and innovation. For manufacturing a chip, first we should know or realize the logic. So for that electronic design, that is where we see all this VLSI or any other design techniques, even software development or whatever it is, using and putting into the chips. That is electronic basic design development using the design automation tools. Those things there also we should be strong, and innovative techniques have to be adapted for power consumption, reducing, and so many other factors. So all these things, so it is, if you see all these things clubbed together, it is like when we want to have a good reasonable standard of living, what we will do nowadays? Okay, in house earlier ladies are more aware of this one. To prepare even idli, it was a very difficult when we were in school. మా చిన్నప్పుడు ఇడ్లీ చేయాలి అంటే మాకు గుర్తు రోల్లో పప్పు రుబ్బాలి అంటే అంత ఇబ్బంది పడేవాళ్ళు. ఈ రోజున ఇడ్లీ ఎవ్రీడే బ్రేక్ఫాస్ట్ అయిపోయింది సింపుల్గా. ఎందుకైంది? బికాస్ ఆఫ్ ది అడ్వాన్స్మెంట్ ఇన్ ది టెక్నాలజీ. Similarly, so many things have taken place. So to develop such things, and now ladies have become employers also, and gents also are contributing very well. So in that scenario, we cannot be present at the particular device, not even near to that. Still we can be in a position to operate it. For that, communication is required, network is required, and without human intervention, some intelligent methodology is required. So all these things, all put together. So one particular system has to work means all these things are involved. Maybe percentage may change. So these are all things in fact required. So these are the areas where the present generation, see in research activity, there is no bar or there is no threshold level. Even some people who are not even qualified, who have studied in textbooks or in normal newspapers, some people, though they are not qualified, they have done wonders in the research. Sometimes scientists, they don't have academic qualifications, but still they have done. And at the same time, a PhD scholar or even a diploma student or a fresh engineering or studying student only, they also can contribute. So idea is important. From where it has come is in fact immaterial. So in research field, every new idea is a new one only. That idea, a 60-year-old professor may get, or a 20-year young boy can get. I am not belittling anyone or boasting anything. It is the fact. So knowledge is important. We should focus on the knowledge and try to improve, find the new things. When we see in research angle, first and foremost important thing is what is the current situation, where we are, what are the things required. Theory is most important. When we know the theory, for example, resistors are connected in parallel, what will be the resultant value? For that you need not connect all the resistors and measure with the multimeter the resistance. So one theory, just I am giving an example. Same way, whatever we think of, for that we should get some idea. Theory background. In this, all the subjects, whatever we study in engineering, that will be of help. So we should focus our subject. For example, I will give an example here. When I was studying engineering, the moment Fourier transform was started, I was wondering, what is this Fourier transform? It's a complicated, I think ఇప్పటికీ కూడా చాలా మంది అమ్మో ఈ పెద్ద లెక్కలు అవసరమా? Many may feel why these are required, but if you really observe, what is it actually signifying? It is signifying, what is it is indicating that? What are all the frequency components available in a particular waveform? And what is the amplitude of it? What is the frequency of it? That is, in fact, it is a spectral representation or frequency domain representation. So that is why it is being used. If we know, then automatically we will come to know the importance, and that will be more helpful in the future. Artificial intelligence in electronics. Here chips are intelligent. The brain is in the chip. So for that, what is to be done? What is actually artificial intelligence? It refers to the artificial intelligence in electronics, refers to embedding intelligent algorithms into electronic system so that they can learn, analyze data and make decisions automatically without human intervention. To understand it more clearly, just I will give an example. Normally in classrooms, lecturer gives or he takes some class and explains some equation and solves a problem which are defined in the textbook. But in the examination, we don't get the same thing. The student will learn what lecturer has told and remembers and analyzes. He learns how to use it, and when the examination, when different parameters and different format, if the question comes, he will apply his learned knowledge, not only the knowledge imparted by the lecturer. Learned knowledge he will use and solve the problem. So where that knowledge is developed, that is through learning process, analyzing this one. Same way, the chips, if they are shown the way how to learn, then they will do the work without the human intervention. So for that, some specialized chips have to be developed. So in this artificial intelligence electronics, parts are chips or processors, sensors. Any electronic system, for example, temperature monitoring is there. There we have to monitor the temperature. Temperature is a different parameter. It is not an electrical parameter. We have to convert that temperature into electrical using a transducer. So that is a sensor. Similarly, so many other things. Just example I have given. So many sensors. For example, height, displacement, whatever it is. So there are different sensors are required. Even for cleaning robo, it will have sensors to monitor even any obstruction is there or not. So all those sensors are required for the system. Those sensors, these are all in fact an embedded system only. Where the difference comes is the chip which has learned the actual process. So that will not wait for any instruction. Normally embedded system means doing the predefined tasks. When we want to update it, we cannot unless change the firmware. But here if you come to know, in this case, embedded system will upgrade itself. Machine learning models, here not only electronics comes into picture. What I want to say, I think you may be having machine learning course also in this college. So those people will be knowing more. In embedded system also, writing the software is the job of a computer science student. And electronics hardware is job of electronics hardware person. So those people all have to work together and make these particular things happen. So what are the applications in consumer electronics? Point వస్తుంది? No problem. ఈ మధ్యలో ఓకే రైట్. మైక్ రావట్లేదా? అదే ఇదైతే కొంచెం కంఫర్టబుల్గా ఉండేది, నేను ఇక్కడే ఉంటున్నా కదా. ఓకే. So if you see artificial intelligence, what are the applications? Consumer electronics. Consumer electronics means, see, normal even TVs, phones, where face recognition, voice imaging, voice recognition or image processing, all those things, they all, if you implement in the existing devices, then without human intervention, we can achieve so many things at a very faster rate. Industrial automation. In the industries, for several applications, logistics, we can use the same thing. And biomedical electronics, analyzing the ECG, or where human intervention is not possible. Normally in medical field, infection is the important point. if humans are allowed, there is a possibility of infection. So where human intervention is to be reduced, there we can use with intelligence. And automotive electronics like traffic management, traffic jam conditions can be controlled smoothly, or agriculture, pest monitoring, crop monitoring, all those things can be done using the artificial intelligence in electronics. Security and surveillance, monitoring where exactly what is happening, all those things. Artificial intelligence in electronics, this has to be focused. Advanced telecom. 5G, if you see, these are all connected, different nodes are connected. Normally in 2G or 3G, connectivity is restricted to a small number. In case of 5G, we can have up to 10 Gbps speed. It's not coming here. Vote laser. Ah. 5G, in fact, next generation, because we are still actually in 4G only. In 4G, we can go up to 1 Gbps speed. In 3G and 2G, its speed was very less. We had already experienced that one. Now for 5G, speed can go up to 10 Gbps. And latency, the moment we give input, output will come within just 1 millisecond. Billions of devices can be connected to the network because of the speed and the format, the way we connect different devices, the physical media used, they facilitate all these things to be done. And high reliability. When we go for this advanced telecom, then only communication will happen fast, and whatever we want, even for example Internet of Things, when we use internet to control so many things, if communication is not fast, that will not be of any use. So this is in fact required. So what actually is to be done by our people in this case, the young engineers, when they get opportunity in any other industry, then they can just see these things. If they know about the networking and the communication techniques, then they can contribute in handling those devices and also in doing some more innovation techniques in that one. With the 5G and even beyond that, we can get smart devices, and internet anyway will be faster because of the higher rate of communication. Autonomous vehicles also can be controlled, remote control of the vehicles, not only just child's play where we give a kid a car and ask him to play. So in real time itself that can be done. Remote surgery means a doctor can be sitting in some hall and he will be directing so many other doctors to do the operation. How that can happen? When the communication, there is no delay, then only he can do such things. Telemedicine. So doctor need not be present in his clinic. He can be available. So we can get the treatment immediately without any delay because of the advancements in the telecom. Smart cities, the cities like Singapore, where entire city is digitalized. So we get all the facilities. So that facilities can be realized only when we have this type of communication. And Industry 4.0, that's a smart system. Every connectivity, unless communication is speed, you cannot achieve anything. If we go for the future, it is even 100 Gbps. 100 Gbps means 10 to the power 11. 10 to the power 11 bits per second. Latency is 0. The moment you get, output will no processing delay. So processing is enormously fast. With such things, we can make best use of the satellite networks, and the artificial intelligence will be more powerful. So one will augment the other. In this case, the frequency of operation is terahertz, not just megahertz or gigahertz. It will be of terahertz frequencies. So it requires something to be developed for the infrastructure. There, development is to be focused. Applications are holographic communication, where we can have 3D images of the people communicating with each other. And this fully immersive augmented reality or virtual reality systems, smart transportation systems, and advanced space and satellite internet. Internet of Things, I think most of you know about these things, how all devices can be controlled. Even a farmer can switch off the motor using his cell phone. He need not go to the farm and switch off. Similarly, parents, when they are alone somewhere else, their status can be monitored, where they are, in which room. The child can operate, take care of the parents, old parents. So that is all, these things are possible only with the use of Internet of Things. In the internet anyway, IPv6 is in fact the latest one, though not used by all, but that is the current one, we can say. It is being implemented. In there, that number of addresses, I mean, that bits are very high. Instead of 32, it is 128. So more number of peripherals can be connected to the same net. In this Internet of Things, we have sensors and actuators. So electronics and basics of other engineering branches are very much important, because without the inputs from them, even intelligence or software cannot do anything. So all are required. So connectivity for this one is either through Wi-Fi or 5G or even Bluetooth also. You can do such things. Anyway, cloud computing, these are all known things only. Data analytics and AI. For learning, we need processing of the data, analyzing the data, then only we can update. Their applications, in fact, are known. And in green electronics and energy storage, here renewable energy sources are most important things. They will not cause much pollution and they will not be exhausted so easily. Solar, no question of any exhaustion. And water, plenty of water will be there. And hydrogen, winds. Using this, if we generate the energy, that will be safe to the environment and no question of exhaustion and need not depend on other countries. Now we see the petrol situation, gas situation. Such things will not arise if we go for such things. So solar systems, nowadays many people are going for this one and using that for different applications, not only for just fan or lights or some other things. So many things, complete conversion. And that energy, whatever is stored, should be stored in a battery or even supercomputers, super capacitors. Toxic substances will be eliminated. For example, even ICs, we get lead free. Lead is toxic. And if you see use of eco-friendly materials, when we go for the green electronics, we have to avoid the toxic and non-user friendly items. The devices, whatever we use, because of the low thickness of the wafers, nanometers, 20 nanometers is in fact the current trend. For that, we require very small voltage only, just 1 volt, not even 5 or 12 volts, 1 volt. When the voltage is less, power consumption also will come down. With power consumption is less, we need not generate too much power. So they will help. The present day requirement is in fact 3C, we can say: cost, compactness, consumption. Consumption of power, energy, area, and then cost, how much you have to pay. So if these three, to cater to all these three, we need relevant technologies. In case of energy systems, lithium ion batteries are the most common things because they are safe, unlike this nickel cadmium or other batteries. And supercapacitors, for short term storage of high energies, supercapacitors are the best option. And hydrogen energy storage, this pumped hydro storage, these are all the new techniques. If we know something about this, definitely we can contribute significantly in the years to come. And electronics in electrical vehicles. In electrical vehicles, we find lot of electronics. So these are all just shown in the diagram. So many parts are there. All are related to electronics only. So without electronics, these electrical vehicles, not only the electrical vehicles, in most of the automobiles, we use electronic systems. Okay. So electronics is required everywhere. In 4G or 5G communications also will be useful for this one. So different parts. Some power electronics where we deal with the high powers. Those things also part of these electrical vehicles. So lot of development scope is there in this also. And this battery management system related to the charging and controlling the motors and different sensors, and most of them are embedded systems. And for infotainment, information plus entertainment, that is infotainment, and connectivity. So Ola cabs or Uber cabs, though they are in the remote area, they are able to communicate with their organization and get the information, billing, everything. So they are all possible with the use of electronic systems in their vehicles. Drones and aerospace electronics. Drones, they also have a lot of parts in this. And aerospace, many electronic systems are there. Drone is nothing but unmanned aerial vehicle. They are light in weight and they operate with different frequencies depending on the type of communication, and they carry some controllers. In that, sensors are required, cameras are there, and anyway to run it, battery and power systems are there. So they can be used for delivery, for monitoring, for even for agriculture throw pest controllers or pests and these pesticides can be thrown, or monitoring the crop condition, giving a visual picture to the farmer. So wherever technology can be used using drones, not only for the present wars. In wars also it is used drastically. Of course that is negative aspect. But in the positive, for daily usage, this can be of very useful thing. In last time, I think Godavari Pushkaralu ఆ టైంలో డ్రోన్లు బాగా వాడారు. అప్పుడు ఇంత వాడకంలో లేవు, కానీ చాలా వాడారు. ఈ టెక్నాలజీని వాడితే స్టాండర్డ్ ఆఫ్ లివింగ్ పెరుగుతుంది. సో టు మేక్ అవర్ సెల్స్ అప్గ్రేడెడ్, టు మేక్ అవర్ లైఫ్స్ కంఫర్టబుల్, దేర్ ఆర్ లాట్ ఆఫ్ స్కోప్ వేర్ డెవలప్మెంట్ కెన్ బి పుట్ ఇన్. For that we need to develop the theoretical background. Of course, disaster management and rescue operations in case of floods, earthquakes, where normal people cannot go, there also help can be extended. In case of aerospace electronics, of course, not only for warfare, for different navigation systems like GPS or Navic, wherever different frequency of communication systems will be there. Radar systems also come under this, control systems and onboard computers in the flights. If you see applications, not only for the commercial aviation, for military and also for satellite communications, and most importantly regularly we see this for weather monitoring systems. Okay. Right, okay, smart manufacturing. Here I will just explain you the way we do in EMSD. EMSD means where EVMs are being manufactured, where there lakhs of units have to be produced. This type of automation is done there, like conveyor or monitoring exactly materials. All these data can be stored effectively using the advanced digital technologies for monitoring. Everything will be monitored by the management as well as our customer. It will reduce the time, labor also will be required less in quantity. And cloud connectivity can be used for data storage without our physical hardware elements. Artificial intelligence can be used, and anyway robotics and IoT, 3D printing, machine learning, these are all the things involved in the smart manufacturing. Any industry which incorporates all these things, they can do things in a wonderful way, not only in productivity, quality, and also in time, in terms of delivery time. ఇది పాయింటర్ అండి, ఇట్స్ నాట్ మూవింగ్. ఇది పాయింటర్, ఇది అంతే. Next. Smart manufacturing. Here this is an example of pick and place. The components are miniature in size nowadays. Some components we cannot see even with our naked eye. They are fraction of millimeters. We cannot see. Such things have to be placed and to be soldered. So, suitable machines and fixtures in our EMSD ECIL, 1 lakh components can be assembled in 1 hour. So that is one of the biggest assembly facilities in the entire India. ECIL and BEL have such facilities. So because of that only mass production is happening, and where we cannot even assemble manually. Some BGS are there where balls come under the IC. How can we solder it? QFN components, we cannot see the visibility. They are under the component pins. Such things are possible only with using this type of smart technologies only. Of course, at present we are taking these equipments from abroad. From foreign companies we are taking these equipments, but using here. We are the user here for this one. If we develop such things, then we can be self-reliant. So that is in fact the aim of the government of India, to enrich ourselves with all the latest technology. When others can do, why we can't do? That is the motto. That is actually the concept behind this Vikasit Bharat. Next. This smart manufacturing industry, not only developing the technology, using the developed technologies for effective operations of an industry. Using all these techniques we are developing. Okay. And for simulating few things, digital twin. Digital twin means creating the digital image for a system. To develop a system and know the problems after developing, instead of that, it is creating an image and doing something on it and know the problems beforehand. So we can reduce the time and other money also, and we can get good results. For that digital twins, all those smart techniques can be adopted in the industry using the latest technologies. Next. Automobile manufacturing. Anyway, if you see any car factory, we find a lot of automation there. So they use all those parts, in fact cannot be handled with the man. So machines are used, those machines are programmed, we will get. In electronics production, as I just now told, our EMSD, where we use these automation techniques for assembly, and of course PCB fabrication also requires such things. Medical device manufacturing, where composition has to be very careful, milligrams have to be seen, you cannot see manual intervention. So highly intelligent and very efficient systems are required. There we can adopt this technology. If we don't have such things, even if we try to fabricate or manufacture such things, it will be hazardous and dangerous, life-threatening. So that is why for medical devices, for pharmaceuticals or medical devices means equipments, as well as some of these pharmaceutical companies also, these smart manufacturing techniques are most required. Earlier we have come to know SAP and management act techniques. That is for management terms. When it comes to technology, we require these smart techniques to improve the productivity, quality. Logistics and supply chain, for movement or monitoring or storing, where without using the intervention, when to take care of that will be done automatically using the smart techniques. All those logistics and supply chain can be handled using the techniques whatever we have discussed earlier. And sustainable manufacturing, that manufacturing process whatever is done, that we can depend without any problem, and we can easily upgrade it also. It can be continued. If it is done for one product, can be used for others also. It cannot go waste. Next. Cyber security and data protection. Actually, security is the most important. Security not only for our properties. In the digitized world, information is our property. We have to protect it. If information is not protected, there are different ways. When we are transmitting information from one place to the other, through a channel, the channel can be intercepted by anyone. Oh, thank you. So in cyber security, different things, not only the software, even the hardware, whatever just now Madam has briefed about me regarding the IP encryptor, whatever we have used. ECL has done a lot of encryption techniques, and in fact, luckily by God's grace, I am one of the designers, in fact it was used in Brahmas also. So to take care of the threats of tampering or blocking that. So cyber security and data protection are important aspects. That is cryptography, you can say. Next. Just I will conclude in 2 minutes. So different models are that we can have a separate hardware model for the different microcontrollers. Here just I would like to tell one more thing. The importance of the VLSI without using the microprocessor. Normally embedded system means we use microprocessor. Without using microprocessor, using the VLSI techniques and the available latest programmable devices, I have devised a new embedded system design methodology called hardware programming based design methodology, with which we can achieve very high latency. For realizing one routine with processor, it may take few milliseconds. Whereas it is done with the technique what I have told, it can be a few microseconds only. So that is in fact using multiple processors at a time for different operations. Multi-core, multiple processor techniques, you can say. Okay. So this cyber security, this is also an important field. Next. Okay, please go to the end. Just I will want to tell regarding the fab what we discussed, sir, earlier. But this is the, one minute. Previous slide, please. This is the in fact aim of our government of India, Prime Minister Modi garu, made in India for the chip. So far we are getting from outside only. Though we have fabs, not able to use it properly because outsourcing only, just packing and other minor operations only are being done. Everything is to be done here only, including the fab as well as the assembly, testing, marking and packaging, ATMP. That ATMP facility must be incorporated. At present we have 4 in operational, but not full-fledged, but most developed. And few more are already approved in different states like Andhra Pradesh and in some north states. Please go next stage. Next. Well, these are the things: Micron Technology ATMP plant, CG Power Renaissance Stars, Keynes Semicon plant, and Tata Electronics plus PSMC, that is a Taiwan-based company. So these are the only facilities available, but still we have. These are the things that in Assam, Odisha, and of course Andhra Pradesh, Punjab, they are approved, about to come forward. And these are the plants where we are going to achieve the chip fabrication within India. This will be full-fledged. This task will be fulfilled definitely by 2047. So this is the vision. This vision is for the benefit of the future generations to come. Next. Electronic design and innovation, here just whatever we know, this VLSI or embedded system or any software development, all have to be done using the design automation tools. What are all the developments that are happening across the globe have to be incorporated, and to develop the thing so that when we develop our system on a chip using software and hardware, then that can be manufactured, that can be fabricated, and it can be used in a system using all the smart technologies. And once the devices are developed, they can be interconnected and human intervention is reduced, so that just you imagine all these things are put together, we will be definitely in a different world. So to take us to the different world which the entire world is eagerly waiting for. Of course all these things are not available in any country, but such things should happen. So that is in fact the vision. So according to that vision, what is to be done by the present generation students, that is then I should congratulate once again the management and the present conveners and the faculty members, heads of the departments and all the connected people including the students for organizing such things here. You have accepted the call by the government of India and trying in that angle, and I wish you all good success and brightful future. Not only for you, it will help all of us for the nation. Thank you. Sorry for taking more time.
Thank you so much for your knowledge sharing, sir. In fact, you have dwelled into a lot of research areas, advancements that have happened across the field of ECE and how it is connected to other disciplines. The brief that you have presented really takes a lot of time to prepare, and you have told it in a very layman language. Thank you so much for your time and your knowledge sharing. Despite your busy schedule, you ensured that we all align in the same line, and you came here to share. Thank you so much, sir. Next, we have our session on bridging academy and industry in renewable energy and electric mobility by Rushali Thakur. This is the next keynote address. To introduce the next keynote speaker, Rushali Thakur, I would request Nagraj sir, Assistant Professor, Department of EEE, to come onto the dais and to introduce Rushali Thakur, ma'am.
Good morning all. It's a great privilege to introduce Rushali Thakur. Rushali Thakur is an accomplished electrical engineer professional who has successfully transitioned from academia to industry, bringing over 20 years of teaching, research and technical experience. She currently works as a quality control and test lab associate at RAN Technology, Netherlands, where she is involved in component testing, quality assurance and compliance with international standards. She has also contributed to the development of advanced lithium-ion battery systems at Intercell Energy Solutions BV. She holds a BTech bachelor's degree in electrical engineering and master's degree with distinction in the control system. During her academic career, she served as an assistant professor and actively contributed for the student development, research and academic activity. She has published more than 20 papers in the international conferences as well as IEEE transactions too. And she is a author for the more book chapters on battery models in energy storage system. Her career begins as an industry as a design engineer working on power and control circuit design before moving into the academia as well as and later transition back into the industry. She has received the Global Eminent Academician Award in the year of 2021 and a research grant for the developing power electronic converter for active balancing of the lithium-ion battery. She is a senior member of the IEEE and currently serves as a global chair for the IEEE Power and Energy Society Expanding Collaboration and Engagement Committee. She is actively involved in the various IEEE initiatives and promoting the innovation, sustainability and women empowerment for the women growth. And I request Rushali ma'am to kindly take over the session. Over to you, ma'am.
Roshali ma'am, you are now live. We once again welcome you to the International Conference on Emerging Trends in Engineering, Technology and Applied Management Sciences, organized by the Research and Development Cell, Vagdavi College of Engineering. May I now request you to please preside over online, making this conference truly a blended mode conference. Dear participants, please be in the auditorium. The session will be live on the screen. Thank you. Rushali ma'am. Ma'am, could you please hold for a minute? You are not audible. We're just making the necessary technical arrangement. No, ma'am. Please, just hold for a minute. Ma'am, you are in mute. Roshali ma'am, could you please unmute yourself? Could you please unmute yourself? Roshali ma'am, you're still on mute. Please unmute yourself. Another call. Yes, ma'am. I think you can speak now. You are it away. Ma'am, you are not audible.
To my mobile.
Thank you, ma'am. Thank you, ma'am. You're audible now. Please go ahead.
Madam, you are not.
Now I am audible. Okay. Right. Now can I start?
Yes, ma'am.
Okay. Okay. Fine. Okay. Thank you so much for introducing me with a lot of experience and all. Thanks a lot. Good morning, good afternoon to everyone. I am Rushali, and it's a pleasure to be here at this conference. I would like to sincerely thank. There is a noise from the other side, I think now. Yeah. I would like to sincerely thank the organizers of this conference for giving me the opportunity to share my thoughts. The theme of this conference focusing on interdisciplinary innovation and sustainable development is extremely relevant in today's world.
Okay, done.
So before I begin, let me share a small real-world perspective from my side. When I was deeply involved in this academic research on battery systems, I used to design models and algorithms that would perfectly fit in the simulations. Everything was efficient, stable, and optimized. But when I moved to industry and started working on the real battery systems, I realized something very important. A system that works perfectly in simulation does not always perfectly work in reality. There are epics in education, but the scenario is completely different when you transfer from academics to industry. You need to build a customized way. We need to design that system. I will show in my further slides how exactly I was working with the battery management system. And the current role I'm playing is every part matters. Am I not in the meeting? Oh. My network is lost. Yeah, audible, but my network is lost, I think so. Uh, I will reach here. Yeah, is it audible? Oh, very soft, very soft. Uh, Yeah. So the current role which I'm playing is at RAN Technology is Quality Control and Test Lab Associate. What I do over here is I inspect the incoming electronic components like GPU, CPU, ICs, those small parts which are used in all the applications of the industries. For example, defense industry, or maybe electrical vehicle industry, or aircrafts and all the components which are used in the in the PCBs and all, those are inspected. You match those parts to the purchase order and the custom specification, test the electrical properties and verify those manufacturing details. You need to upload the test results and maintain the digital records, and these are all have to work under the standards, ANSI standards, standards, ISO standards and all. So you should be able to learn what are the standards, because whenever we do projects and all in our academics, we are not very much involved in all those standards and all. The standard practices we don't follow. We don't follow those ISO rules, but that are very important, and that should be one of the key aspect when you are designing or doing any project. The next is the outline of the presentation will be before I would like to just start with an introduction and context where I will set the stage by discussing the global current challenges related to energy demand. Slowly we'll move to the energy transition. We will also discuss the role of academia and industry. How do they complement each other? And this will naturally lead us to one of the important aspects of my talk, which is bridging the gap between academia and industry, understanding the existing challenges and exploring the ways to create a stronger collaboration. Maybe if the time permits, we can see a case study from my own experience, particularly in the battery systems and the electrification. And finally, we will conclude with the emerging trends, where I will briefly touch upon the future directions such as smart energy systems, AI integration, and advancements in battery technology. Let's move to the introduction. The world today is facing two major pressures. One is rapidly increasing energy demand and an urgent need to reduce the carbon emissions. We are currently living in a time increasing rapidly due to the population growth, urbanization, and technological advancements. At the same time, climate change is pushing us to rethink how we produce and consume the energy. Electric mobility and renewable energy systems are emerging as the powerful solutions. I had seen the previous talk also, Harinath sir, he was also discussing about the artificial intelligence and about the various technologies. So these technologies require not just innovation, but collaboration. Academia focuses on research, knowledge creation, while industry focuses on implementation and scalability. So if these two sectors work in isolation, progress becomes slow. But if they collaborate, innovation becomes faster and more impactful. If you look at the global energy transitions, in 2025, renewable energy has reached 49% of global electricity capacity, up from about 46% just a year earlier. So if you see solar alone, see these all statistics are already available, but I just want to make you aware of the figures which are coming in the recent years. So solar alone had added over 500 gigawatt in 1 year, making it the fastest growing energy source globally. And also, if you must have seen about the vehicles, about the EV adoption, some countries are leading, like for example, Norway is over 80% of EV adoption. China, about 50% of new car sales are electric. And India is also growing rapidly, crossing 2 million EV registrations in 2025. So this shows that EV are no longer experimental and they are becoming the mainstream. So behind this EV revolution is the battery ecosystem. If you look at the global battery demand, it is 1 terawatt hour in 2024, which is a historic milestone. To put this into perspective, at the same time, the transition is not just about replacing the technology. It requires rethinking entire system, including energy generation, storage, and distribution. This is where advanced technologies like smart grids, battery system, and intelligent controls systems play in. If you see the role of academia, academia plays a foundation role in the ecosystem. Universities, research institutions are responsible for developing new theories, models, and technology. For example, if I take a battery system, academia will work on improving the algorithms for state of charge estimation. Those who are into pure electrical field, they will come to know, yes, we developed the algorithms for state of charge of estimation or developing new balancing techniques. However, while academia is strong in theory and innovation, it often lacks exposure to the real world constraints because real world constraints are cost, reliability, and scalability. So industry, on the other hand, focuses on converting ideas into real products. It deals with the challenges like manufacturing, system integration, cost optimization, and meeting the market demands. So for example, if you have designed a battery system in the lab, it is very different from deploying it into an electrical vehicle where safety, durability, and environmental conditions are critical. So industry ensures that technologies are practical, reliable, and scalable. If you look at the gap between the industry and academia, despite there is a gap, yes, students often graduate with strong theoretical knowledge, but limited hands-on experience. And at the same time, industries struggle to find the engineers who are ready to work on real systems immediately. This is another challenge is that academic research may not always align with the industry needs, leading to slow technology transfer. And bridging this gap is essential for faster innovation and better outcomes. How to bridge this gap now? So we need strong collaboration mechanism. One of the most effective approaches is internship. I generally say that whenever you are in the final year, students don't do the in-house project, try to do the out-house, try to go into industry, try to with the industry, try to solve their problem statement which are given by the industry, which would help you in getting into industry. And maybe not now, it's like not getting into industry, but have your own startup, right? So that should be your aim, not to work for a company or try to work for a company for 1 or 2 years, understand how the company works, and then try to have your own startup. And you try to have an empowerment, give that jobs which are available, you try to give it to others. So why you want, that is my always this thing, why you want to work for anyone, try to give the jobs to create the job opportunities for others. Joint research projects between universities and industry can ensure that research is aligned with practical needs. I have seen that when I've shifted to Netherlands, in India, we have seen that PhD is like, we do the project, we publish the papers and all, but what after that? I think so. Out of 100%, only 10% may have started their own startup with the research carrying on. There is no, that is the need now, that you should have that joint research project between the industries. That connect has to be built up. We just stopped doing after research. Yeah, that's it. We have published a paper, we got a PhD degree, and that's it. No, but just try to have beyond that. How you're trying to implement whatever research you have done and how it is useful to the community. That should be your aim. Industry-sponsored lab and innovation centers can provide students with hands-on experience. Additionally, startup ecosystems, innovation centers can help transform the research ideas into commercial products. So this is the figure you can see here, the battery system, and how we just try to see the image which is shown here with the battery system. It is a whole battery building system for of a 200 ampere battery pack, which is used in a core drilling machine. So these type of projects I was working on when I was in an industry, in Intercell. So I had to develop the whole battery modular system. Along with that, you can see there are PCBs which are lying. So those are the passive balancers. Connecting it with the high voltage, low voltage circuit. Testing it, whether the cells are balanced properly or not, and then you need to supply it to the customer. So this is when I was doing my research, it was a very small type. It was hardly 24 volt. I had made a prototype. But when I came into an industry, it was not a small prototype. It was a huge battery pack which we have to build up for different applications. For example, core drilling. I had also worked for 100 ampere lithium ferrous PO4 battery for electric forklift. So these are all the machines where they were trying to replace those fuel generated with the battery. So that was the ecosystem for sustainability. So these projects require just not theoretical understanding, but practical skills in assembling, testing, and system integration. So mechanical and electrical, both knowledge you need to have when you are developing an electrical system, and plus your software IT knowledge. So it is now, it's not only one stream which you have to work on, it's a multidisciplinary engineering knowledge you should have. So these projects require system integration, testing and validation, safety compliance, and this is where theory meets the reality. These are few of the emerging trends in the energy sector. I believe that the earlier keynote speaker also was talking about these energy trends, about the smart grids, which are enabling the better integration of the renewable energy sources. Artificial intelligence is being used for predictive maintenance and energy optimization. This is particularly, I'm telling you, for the energy sector. IoT devices are enabling real-time monitoring of energy systems. So there's a huge scope for the researchers, for the graduate, undergraduate students to work on the problem statements which are faced by the industry. Battery technologies are also evolving with advancement in fast charging, energy density, and life cycle performance. So these trends require interdisciplinary collaboration across the multiple domains. So what are the skills which are required for the future engineers or for the researchers? So they must have strong fundamentals in whichever field you are working. If it is an energy sector, it has to be an electrical engineering with practical skills in simulation and hardware implementation. Programming skills is equally important. And most important, an engineer must develop a problem-solving mindset and the ability to work across the disciplines. So he has to have the soft skills, the hard skills, the technical skills, and also the networking, because making connections also helps with the industry professionals and mentors. You get good mentors. If you are stuck on somewhere, there are always mentors who will be able to help you. So to strengthen the connection between academia and industry, several steps are needed. Institutions must actively promote the collaboration through joint programs and research initiatives. There should be a greater emphasis on applied research and real-world problem solving. Startup ecosystems and incubation centers should be supported to encourage innovation. And yes, policymakers and funding agencies also play a critical role in enabling this. We should not forget those, because even if industry and academia, they try to connect, because of the policies, because of the funding issues, we are not able to go ahead. So that also plays a critical role in enabling these collaborations. So I would like to conclude saying that the challenges we face today, energy demand like climate change and all, cannot be solved by academia or industry alone. Collaboration between the two is essential for innovation and impact. And by working together, we can develop technologies that are not only innovative, but also practical and scalable. So together, we can build a sustainable and energy efficient future. Thank you. If you have any questions, I would be happy to take. And you can definitely connect with me on LinkedIn, and any questions I'm ready to take. Thank you so much for inviting me here. Any questions?
Good afternoon, madam. So thank you very much for your presentation. So,
hello, sir.
Yeah, thank you very much for your presentation. But as far as our Honorable Prime Minister's dialogue, the Viksit Bharat, but there is a lot of gap between the academia, industry, and the government. So in order to eradicate this gap between the academia and government as well as the industry, so as a young researcher, that how that what is your objective and how that what you propose? So because there is a need to eradicate this gap, because the gap is existing for the past several years, because for the past several years the academia is striving hard to bridge this gap, but all these efforts are in vain. Then what is your effort? What is your opinion, please?
Sir, a little clearer. I was not able to hear you very properly. I understood like what funding policies are you talking about?
No, no, the funding policies are there. The funding policies doesn't eradicate the gap, because there must be some great efforts must be done from part of the government. That's what I
Yeah,
feel.
true.
That was as
Yeah,
an
so
young
there
researcher. So what is your opinion?
there are different organizations, there are NGOs, and even IEEE supports. Now, which I had submitted for this greater startup. That is even IEEE Power Electronic Society. If you submit all those the projects which are given by the students, if you are giving it to the PES Power Electronic Society, or if you are even giving your problem statement or the solution to the Epics in educational activity, they sponsor 10,000 USD for the project, which is helpful for the humanitarian project. So whenever you are doing any project related to the for the betterment of humanity or humanitarian activity, these projects are sponsored by, because I am also a part of Epics in education activity, where we try to evaluate the projects which are helpful for the students. So they provide around 10,000 USD for the projects. So, no, naturally, we need to have also the collaboration between the government agencies as well as with the industry and academics. So, all the three, if they are together, they are working, definitely we will be able to give a sustainable solution to the community.
Okay.
Ma'am, myself Dr. K.
Yeah.
Prakash, and I want to know about the research activity which is really taking place with respect to AI usage in the battery management systems, BMS. Am I audible?
BFS.
Madam.
Sir, actually, the audio is very unclear, so I'm not able to get the question very clearly.
Yeah. Is it clear, madam? Is my
I'm
voice is
hearing,
audible?
yeah.
Yeah. See, my
Yes, you are audible.
my question is, what is the research activity which is taking place, the usage of artificial intelligence in the battery management systems?
Okay. I got your question, sir. I got your question, sir, Venkatesh, sir. If you are using artificial intelligence, I will tell you through my own example. When I was doing my research, I didn't use artificial intelligence in my research work. So that time, when you try to publish your paper, they will say, no, there is no innovation, there is no, you have just created an algorithm and you are trying to say that you are trying to balance the cells. Later on, I realized that only this work will not be sufficient, because you need to incorporate some artificial AI algorithm. In my research work, I included using Red Panda optimization algorithm to balance the cells. So without that, when I stimulated my prototype with the artificial intelligence optimization algorithm, and without, I could see that the efficiency or the losses which were there were quite comparable when I did it with AI. They were quite good. The efficiency was higher than that without, if I'm using the artificial intelligence. So AI has to be incorporated, because it, along with that machine learning, the data which we are giving, it is learned. So they learn the data which is given when I was doing the testing during charging, discharging and all. So based on those, they had modified the algorithm, artificial intelligence Red Panda optimization algorithm. And based on that, I was able to get the good results. So yes, AI is very important for this.
Madam, one more question.
Yes, sir.
Yeah, what type of algorithms you recommend with respect to artificial intelligence for the usage of these electric vehicles and BMS in particular?
Yeah, there are various algorithms, sir. For example, when I used in my battery BMS or these things, I had used FFT and for that various optimization techniques and all. But depending upon upon my situation where I had used, those algorithms were not very much, you can say, were not giving much better results. And that's why I had used that Red Panda optimization algorithm. So those algorithms you can easily find out, various algorithms you can find out in any of the textbooks. but you need to choose the right algorithm, which algorithm will focus depending upon the constraints which you have. So I was having the constraint, I took a constraint as a temperature. So I wanted to balance the cells, having a constraint as a temperature. And that's the reason I had chosen that algorithm. So there are different algorithms which are given already in the textbooks.
Yeah, thank you, madam.
Yeah.
Good afternoon, madam. This is Dr. Sirisha.
Yes.
It was a
Yes.
quite interesting talk, and we are glad to hear from you. And this is
Thank you, ma'am.
we are glad to know that you are working in the QC department. So can you just explain or elaborate regarding the application of that is AI plus QC and quantum computing? All this, in what way is the job role changed? Do you use AI on a regular basis in the QC department? And as you were saying a few hours back, in your research you have used it, but in the RAN technology, are you applying on a day-to-day basis the AI?
Right now, where I am working as a control this thing, we are specifically, because when we are looking at the semiconductors, all those small chips. So there, what we do is we try to test all the small components. We have decapsulation test, we have electrical test, we have solder test, we have XRF, all those tests to determine what are the components present in those materials, in those semiconductors. Like we have lead, we have chromium, and also those small components, what quantity is used. For that, we have there is a software which is developed, which is through AI, and through that we can have a test report generated. So that is AI is built in all those testings when we test all those parameters.
And the way you are doing it earlier and presently, is there a difference in the way that you are?
Earlier we like when I started, I recently started working as a quality control. So before that, they used to do manually. What are the what are the components present? What is the percentage present? But now, since AI has come, it is easy for us to generate the test report of the decapsulation, or what are the XRF. That means what are the components which are present, small components which are present in that particular chip. Then we also conduct the solderability test and all. So those, for solderability test, we will not have AI, because we need to dip that particular chip into that. So there we will not have. But where the manual work can be converted into AI, yes, there we have those softwares developed already, and we get the test report automatically generated.
So probably the defects are reduced in the QC department.
Yes,
It is becoming
yes.
more proactive than being reactive. Earlier in the manufacture, QA would take care of, and in the post-production, the QC, the defects were identified and the root causes were studied. But with the application
you are
of
right.
AI, I think the defects have been avoided to a lot extent. Is it practically?
Yes, we also generate the non-conformance reports. Like if even packaging is also very important. When you are trying to complete packaging in reel, packaging tape and reel factory machine, all those, that is also very important when AI comes into picture, because we have to generate that non-conformance report. If it is not in tape and reel, then we need to make a report generated, and then we have to send it to the customer saying that, oh, this is not the case. We need to retest it. And even we do the test for Cisco also. So they have their own test report generation in the format which they need. So we need to give the, what is the need of the customer, that has to be identified. What tests they want from that, because those are the chips which has to be integrated in the PCB layout.
Yeah.
So for that, yes, AI is definitely helpful for us in finding out, making the test reports, doing few of the tests for us.
And the personnel, are they trained well on AI and in the QC department, working in QC? Are the personnel being trained well in this? Because not all are aware of the AI technology. Are there any training programs going on?
Yeah, we give the trainings. The training is given first to the new joinee, and also training is given always. but it should be willing, that person should be willing to study that, because every time reskilling and upskilling is very important for anyone who joins the industry, because no one knows what is happening in industry. As per in academia, we do everything. We think that, oh, we know everything. But when you come to industry, we have to have a patience, and we should be able to learn what is there. So initially, it was a challenging for me also, because after 20 years of teaching into academics and shifting into industry was not a very easy task for me also. I had to learn many things first, and then I was able to implement it.
Okay.
So that training is given by the company, or maybe in a 1 month or 2 months, we are able to get that training, and then we can work on standalone.
Okay, ma'am. Thank you. Thank you for your patience answering, and glad to listen from you. Yeah, beautiful speaker from a beautiful place of Netherlands, which I visited in 2012 for a conference sponsored by SERB. Yeah. Thank you, ma'am.
Yeah. Okay. Okay. Thank you.
Any more questions? Thank you so much, ma'am, for the engaging session. It was very interactive, and you had answered the questions in a very clear, concise, and precise manner. And one important subtle message that you left was that learn, unlearn, and relearn. When you said that you transited from teaching to the next, that's industry, that is where you also learned. So it tells us that we always are lifelong learning, and conferences are one such place where there is a collaboration and learning opportunity for every age group and for all mindsets. Just for the knowledge of the house, this conference is having participants from 3 countries, 8 Indian states, and about 320 papers. And there are 3 keynote talks. So this really makes it truly inspirational for everyone involved to gain a lot of weightage, knowledge for their own wisdom and to apply in their own lives. Thank you so much for being part of this conference and enlightening us with your expertise, ma'am. Thank you. Now we will...
Thank you. Thank you so much.
You're welcome, ma'am. Now we'll quickly head for a break, post which the presentations in the respective tracks and venues will be known to you. Please reach out to the registration desk for further details. There are snacks being served outside, so you may please help yourselves with the proceedings. Thank you so much for joining the inaugural and the keynote sessions. Thank you so much. Once again, all the very best and congratulations to all the participants for your presence, and best wishes for your presentation in the conference.
To create a